So now we're going to look at inverse images. So let's start with our definition here. For a function f from a to b and an element b and b, the inverse image of b is defined as all the elements a and a where f of a equals b. So it's all the first coordinates of f whose second coordinate is b. So the first thing that's kind of clear from this definition is that f inverse of b is a subset of a. And you can really tell that just by this part right here. All the elements of f inverse of b come from a. Now we can also take the inverse image of not just an element. You could do the inverse image of a set. So we'll say for a subset D of B, f inverse of D is going to be all the elements of A where f of A is an element of D. So one thing I'll note here is that if D is B, f inverse of B is going to be the set A. So let's look at an example. For a function f from a to b where a is going to be the set, a, b, we're going to use our same example from last time, and b is 1, 2, 3, 4, 5, 6, defined by f is a3, b5, c relates to 2, d relates to 3, and e relates to 6. I want you to find the following. F inverse of 3. So you're going to look through your ordered pairs and see when is my second coordinate 3. So here my second coordinate is 3, and here my second coordinate is 3. And so you're going to look then in those cases at your first coordinate, A and D. So f inverse of 3 would be the set A and D. Now you might also consider looking at this visually. So let's draw our function here. A, B, C, D, and E. And then I'm mapping 1, 2, 3, 4, 5, 6. And then we're going to draw arrows. So this is the same diagram we had in our last picture. A goes to 3, B goes to 5, C goes to 2, D goes to 3, and E goes to 6. So here we're looking at f inverse of 3. So I'm looking at 3, and I want to know which elements arrow into 3. So there are 2 arrows coming into 3, one from A and one from D. All right. So let's look at B, f inverse of the set 1, 3. So this is all of the elements that either get mapped to 1 or get mapped to 3. So again, you're going to take, here I have more than one element, but you're going to look at both of these and see which arrows do I have coming in to these and from where. Well, 1 has nothing coming into it, but 3 has an A and a D here coming into it. So this f inverse of 1, 3 will be the set A, D. Let's look at f inverse now of 4. Okay. So if I'm looking at f inverse of 4, that means I'm looking over here on the right. We're going to circle 4, and there are no arrows coming into it. So this will be the empty set. And finally, if I look at f inverse of B here, so now I'm going to take everything in B. So 1, 2, 3, 4, 5, and 6. Take everything in B. Well, and find all of the things in A that went to those elements. Well, right, all of these elements from A have to have arrows going into elements in B. So here, f inverse of B would be A, B, C, D, and E, i.e. f inverse of B is the set A. So let's look at one more example that doesn't contain finite sets. So let's look at, for example, the function from R to R defined by f of x equals x squared, right? So remember, if you want to think about it in terms of relation, it's an ordered pair, right, where R cross R such that y equals x squared. And I want us to find the following. So I'll just say find full. So A will be, I want you to find f of 3 to infinity. So here we're taking, remember, we can take subsets of R. So here the interval 3 to infinity, that is a subset of R. And what we're going to do is we're going to look at the graph of this function, y equals x squared. Right, that's our parabola. And here, I'm focusing my attention on the input of this function, so my x value being in this interval, 3 to infinity. So what that means, let's say this is where 3 is, I'm looking at the x values including 3 and going off to infinity. And so for my function, this corresponds to this point right here where, because this is this x squared function where y is 9, and then my graph going up here. So what are the y values that I'm getting here? I'm getting 9, and then my graph is going to keep going up, so 9 and upwards, which means that my y values, if I look at that as an interval, it would be from 9 to infinity. So here, f of 3 to infinity would be 9 to infinity. All right, so now let's look at the inverse image now. So b f inverse of 3 to infinity. So now because I'm looking at the inverse image here, so let me give myself some space here. I'm going to redraw my graph. But now, because I have f inverse here, these values I'm looking at here are now y values. So I'm looking at y being from 3. So here, let's say here's 3. I'm looking at y being from 3 to infinity. So which points on my graph have these y values? Well, if you look here, I'm going to draw this dotted line to help me out here. There's really 2 parts of my graph here with those y values. This part and then this part. And so if we think, because y is 3, what would these x values be? This would be square root of 3 and negative square root of 3. And so if I look at each one of these pieces, my x values would be from here to here for the second piece, and then from here to here for that first piece. And so f inverse of 3 to infinity would be negative infinity to negative square root of 3 union square root of 3 to infinity. And these should have been, these should have been brackets here. So there's my inverse image. Those are my x values that give me y values that are in this region right here, or that interval there. Let's do some more of these inverse image ones. So let's look at C. C is going to be f inverse of 3, 5. So look at your, and repeat it where you draw the picture and see what x values are you going to get. You're going to get from negative square root of 5 to negative square root of 3 union square root of 3 square root of 5. So I'm not going to draw the pictures for these, but you should, just like you did on part B. So if I look at F inverse of negative 1, 3, this would be negative square root of 3 to square root of 3. And then our last one we're going to look at is F inverse of negative infinity to 0. And that's the empty set. There are no y values with negative numbers in them.